Welcome, dear students, to the next video lecture in atomic structure. So in the last video lecture we discussed about Rutherford's atomic model. Okay, so before going to the drawbacks or limitations of Rutherford, we will see what other conclusions are there that we can draw from Rutherford's model. So from Rutherford's model we have seen that the whole mass was concentrated at the nucleus, and the nucleus comprises of neutrons and protons. So neutrons and protons. Okay, so now see, we will define some basic concepts like atomic number. Okay, so what is atomic number? Atomic number is number of proton. Okay, and it is represented as Z. Okay, alphabet. So this is called atomic number, number of proton in an atom. Okay, now we have a notation capital A, and this is called mass number. Mass number, and mass number is number of proton plus number of neutron. Okay, number of proton plus number of neutrons. Okay, so for any neutral atom means atom with no formal charge. For any neutral atom, number of proton is equal to number of electron. Okay, so suppose if we are talking about a sodium atom, sodium is represented as N small a, sodium Na. This is the symbol for sodium. So sodium has an atomic number of 11. Sodium has atomic number 11. So what does that mean? It means that sodium atom contains 11 proton and 11 electron. Okay, now this is neutral sodium, but sodium can form ions also. Okay, what kind of ion sodium can produce? Sodium can produce a cation, that means one positive charge, plus Na plus. And what Na plus means? Na plus means that it has the same number of proton, but it has lost one electron. So since one electron has been lost, so the number of proton will increase by 1. That's why there is a positive charge over here. Okay, because what is happening in the neutral atom, the number of proton, that means positive, and number of electron, that means negative, are equal. So they cancel out each other and the effective charge over sodium is 0. But in this case, number of electron is 1 less than the number of proton. Okay, so the effective charge is plus 1, so represented as Na plus. In the same fashion, if electron increases, negative charges will appear. Okay, we will see those things, that means how ions are formed in detail later. Okay, now so since we know what is atomic number and what is mass number, we will see something like we will define some concepts like isotopes. So what is isotope? So elements having isotopes having same atomic number but different mass number. Okay, so if two things have same atomic number but different mass number, then they are called isotopes. Like hydrogen, suppose if we take example of hydrogen. Okay, so hydrogen has three isotopes. One is called protium, and protium is 1H1. Okay, so this is actually a representation of atom, and any atom is represented like this. Okay, this is atomic number, this is mass number, and this is symbol of the atom. Like suppose if we take sodium, then sodium has atomic number 11 and mass number 23. So sodium will be represented like that. Okay, this is the atomic number and this is the mass number. So hydrogen has three isotopes: protium, deuterium, and tritium. Okay, in nature generally this form of hydrogen is the main constituent of total hydrogen. Okay, it's 99% of hydrogen is protium actually, and rest is deuterium and tritium. Okay, so these are isotopes of hydrogen. Similarly, you can see that a carbon has also two isotopes. This is the normal carbon, okay, that we encounter in our day-to-day life. Okay, C12, okay, and this is a radioactive carbon, C14. C14 is radioactive in nature. What do you mean by radioactive? I will tell you the radioactivity thing, what is radioactivity. But for now, just you keep in mind that carbon, this is one carbon 12 and carbon 14, and since they have same atomic number, so they are isotopes of carbon. Okay, then we have another concept that is called isobars. Isobars, and isobars are those which has same mass number but different atomic number. If two element has same mass but different atomic number, then they are called isobars. For example, carbon and 14 nitrogen, they are isobars. See, their mass is same but their atomic numbers are different. Okay, so this is called isobars. Okay, so these are the two definitions that are given in NCERT book, but I will tell you some other definitions also. One is isotone. Isotones. Isotones are those which has same number of neutrons. Same number of neutrons. Okay, so say we have carbon 14 and oxygen 16. Okay, so see, this is mass number and this is atomic number. So mass number is what? Number of neutron plus number of proton, and number of proton is what? Number of proton is nothing but atomic number, Z. Okay, so in this case mass number is 14 and atomic number is 6, so number of neutron will be what? 8. 14 minus 6 is 8, so you will get 8 neutrons. Okay, 8 neutrons in C14. Similarly, if you deduct atomic number from the mass number of oxygen, you will get 8. So number of neutron is 8 in both the cases. So they are isotones. Okay, now there is one more species that is called Isoelectronic. Isoelectronic. Isoelectronic means same number of electron. Like suppose I have fluorine negative, neon and sodium positive. Now see, atomic number of fluorine is 9, atomic number is 10, atomic number is 11. Now see, if fluorine is neutral, if there is no charge, then number of proton is 9 and number of electron is also 9. But since it has a negative charge, that means there is one extra electron. So number of electron in fluorine will be what? 10. Neon has no charge, so definitely number of proton is equal to number of electrons, so it has 10 electron. And now see, in sodium there were 11 protons and 11 electron, but since there is a positive charge, so electron will be one less, that means it has also 10 electrons. Okay, so fluorine negative, neon and sodium, all of fluorine negative, neon and sodium positive, all of them have 10 electrons each, so they are called isoelectronic. Okay, isoelectronic. Okay, so this is isotopes, isobars and isoelectronic species. Now since we know all these things and we know how to represent an atom, this is how we represent an atom, okay, with mass number and atomic number. Okay, so now we will go to limitation or drawbacks of Rutherford model. Okay, drawback or limitations means what Rutherford model cannot explain, why Rutherford model failed to explain atom completely. So the first problem with Rutherford model was that it fails to explain the stability of an atom. It cannot explain the stability of an atom. And why it cannot explain the stability of atom? So to know that, we have to know a theory given by Maxwell. Okay, Maxwell, James Clerk Maxwell, Scottish physicist. He said that any charged particle undergoing accelerated motion will radiate energy. Okay, they will radiate energy in the form of electromagnetic waves. We will discuss few things about electromagnetic waves later, but just see that if a charged particle is under accelerated motion, and mind it, the motion should be accelerated in nature, okay, not the uniform motion. If it is uniform motion, then no energy will be radiated, but if there is accelerated motion, then energy will be released. Radiated means it will come out of the charged particle. So if it is under accelerated motion, it will radiate energy. Okay, now using Maxwell's theory, Niels Bohr was another scientist. Niels Bohr, he said that Rutherford is incorrect. Okay, Rutherford model has a serious consequence or mistake. And what was that mistake? What is the problem? So just keep this theory in mind, that accelerated charge will radiate energy. Now see, the Rutherford model was like this, that there is a nucleus and electron is going around the nucleus in circular orbit. Okay, is going around the nucleus in circular orbit. So if you know basic principles of physics, then you will definitely know that in a circular motion, when anything is moving under circular motion, there is always a acceleration called centripetal acceleration. So this centripetal acceleration is necessary for a circular motion. That means if electron is going in this circular orbit, then it must have a centripetal acceleration. That means electron is under a accelerated motion. Now electron has charge, okay, it has a minus charge, negative charge. So it is a charged particle. It is in circular motion, that is, it is under accelerated motion. So according to Maxwell, it will lose energy, it will radiate energy. Okay, and I must tell you that Maxwell was correct. We experimentally know that if a charged particle is under accelerated motion, it does radiate energy. Okay, so it will radiate energy. So if it radiates energy, then what will happen? Its path will shrink, it will keep on losing energy, and path will shrink, and it will finally fall to the nucleus. So what will happen, if electron loses energy, then its path will shrink and it will finally fall to the nucleus. Okay, and if electron falls to the nucleus, then no atom will exist. And if atom cannot exist, then how we are existing? We are made up of atoms only. The whole universe is made up of atom. Okay, so if atom cannot exist, then how can universe? Okay, so this is one of the problem with Rutherford's model, that he cannot explain that how atom is stabilized. Okay, how atom is stabilized. Okay, now secondly, Rutherford model fails to explain hydrogen spectrum, or you can say line spectrum. Okay, hydrogen spectrum or line spectrum. We will discuss a topic which will deal with spectrum. Okay, we will talk about it in the later part, that what is a spectrum, what is hydrogen spectrum, what is line spectrum. We will talk in detail, but for now you just keep it in mind that there is a phenomenon, something that is called hydrogen spectrum, and in 19th century it was a very big mystery. Okay, তেতিয়া বহুত হাল্লা আছিল এটোলৈ যে হাইড্ৰোজেন স্পেক্ট্ৰামটো কেনেকৈ ফৰ্ম হয়, ঠিক আছে। আৰু আমি চাম হাইড্ৰোজেন স্পেক্ট্ৰামটো একচুৱেলি আমাৰ নৰ্মেল যিটো কনচেপশ্যন আছিলে স্পেক্ট্ৰাম লৈ, তাতকৈ হাইড্ৰোজেন স্পেক্ট্ৰামটো অলপ ডিফাৰেণ্ট হয়, লাইন স্পেক্ট্ৰামটো অলপ ডিফাৰেণ্ট হয়। চ' আমিতো জানোৱেই যে আমি ছায়েন্সত কি কৰোঁ, আমাৰ কিবা এটা হ'লে আমি ছায়েন্সত কি কৰোঁ, আমি কাৰণটো জানিবলৈ চেষ্টা কৰোঁ যে এনেকুৱা কিয় হ'ল, হয় নহয়। চ' চাইণ্টিষ্টে জানিব বিচাৰিছিলে যে হাইড্ৰোজেন স্পেক্ট্ৰামটো তেনেকুৱাকৈ কিয় ফৰ্ম হয়, বেলেগ ষ্টাইলত ফৰ্ম কিয় নহয়, ঠিক আছে। চ' ৰিজনটো জানিবৰ কাৰণে, হাইড্ৰোজেন স্পেক্ট্ৰামৰ ৰিজনটো জানিবৰ কাৰণে এটমৰ ষ্ট্ৰাকচাৰটো জানাটো বহুত দৰকাৰী আছিল, ঠিক আছে। ৰাদাৰফৰ্ডে যেতিয়া মডেলটো দিলে, ৰাদাৰফৰ্ডৰ মডেলটো ইউজ কৰি আমি হাইড্ৰোজেন স্পেক্ট্ৰামটো এক্সপ্লেইন কৰিব নোৱাৰোঁ, ঠিক আছে, আমি নোৱাৰিম। চ' ডেফিনেটলি নোৱাৰিম। যদি ষ্টেবিলিটি যদি এক্সপ্লেইন কৰিব নোৱাৰে, তেতিয়াহ'লে ৰাদাৰফৰ্ডকে বেটাৰ এটা আমাৰ এটমিক মডেল লাগিব। উই উইল নিড আনাদাৰ model for the atom. Okay, and we will get a new atomic model, but before going to that new atomic model, Okay, we have to know few things. Okay, we have to know few things. Okay, the first thing that I will discuss with you, I will just discuss simple qualitatively, that is, I will just give you a simple idea about these things. Okay, the first thing that I will discuss with you is electromagnetic wave. Electromagnetic wave. So what is electromagnetic wave? Okay, now you all know what is wave. So wave is something like this. You must have studied it in high school. So wave is something like that. It is wave is something like it goes around a mean position. Okay, it oscillates around a mean position. Okay, and there are two types of wave generally. Okay, two types of wave. Okay, suppose I have a string. Mor hatot dori eta ase, moi wallot etu wallot moi dori tu bandi disu. এতিয়া যদি মই স্ট্ৰিংটো ভাইব্ৰেট কৰোঁ তেতিয়াহ'লে স্ট্ৰিংটো কি কৰিব, এনেকৈ অচিলেট কৰিব, স্ট্ৰিঙত ৱেভছ ফৰ্ম হ'ব। কিন্তু চি এই ৱেভটো মোৰ হেণ্ড আৰু ৱালৰ মাজত কি আছে, মাজতে বাইণ্ড হৈ আছে, এই ৱেভটো ট্ৰেভেল কৰা নাই। ঠিক আছে, চ' দিছ টাইপ অফ ৱেভ ইজ কল্ড ষ্টেণ্ডিং ৱেভ। ষ্টেণ্ডিং ৱেভ। অ'কে, এটা ৱেভ য'ত ষ্টাৰ্ট হয় তাতে যদি ঘূৰি আহে তেতিয়াহ'লে এইটো আমি ষ্টেণ্ডিং ৱেভ বুলি কওঁ। ঠিক আছে, কিন্তু আমাৰ কিছুমান ৱেভ আছে যিবিলাক ষ্টেণ্ডিং নহয়, ট্ৰেভেলিং ৱেভছ, লাইক চাউণ্ড ৱেভ। ঠিক আছে, চাউণ্ড ৱেভটো কি হৈ আছে, মই যিটো কথা পাতি আছোঁ এই আমাৰ ক্লাছৰুমৰ যদি লাষ্ট বেঞ্চতো কোনোবা ষ্টুডেণ্ট বহি থাকে শুনা পাব, বিকজ চাউণ্ড ৱেভটো ট্ৰেভেল কৰি তাৰ ইয়াৰ ড্ৰামছলৈকে গৈ পাব। তোমালোকৰ মোবাইলৰ স্পীকাৰৰ পৰা যিটো চাউণ্ড ওলাইছে এইটো ট্ৰেভেল কৰি তোমাৰ কাণত ইয়াৰ ড্ৰামছত আহিছে, সেইকাৰণে তুমি শুনিবলৈ পাইছা। তাৰমানে দিজ আৰ ট্ৰেভেলিং ৱেভছ। অ'কে, চ' ইলেক্ট্ৰমেগনেটিক ৱেভছ আৰ ট্ৰেভেলিং ৱেভছ। অ'কে, এণ্ড হোৱাট কাইণ্ড অফ ৱেভছ আৰ ইলেক্ট্ৰমেগনেটিক ৱেভছ? চ' ইলেক্ট্ৰমেগনেটিক ৱেভ এনেকুৱা হয়, তোমালোকে যিটো ইলেক্ট্ৰিচিটি আৰু মেগনেটিজম পঢ়িছা তাত তোমালোকে এটা বস্তু জানা যে ইলেক্ট্ৰিক ফিল্ড যদি চেঞ্জ হৈ থাকে তেতিয়াহ'লে এইটো মেগনেটিজম প্ৰডিউচ কৰে। তাৰমানে তোমালোকে এনেকুৱা এক্সাম্পল চাইছা ডেফিনেটলি, যে এটা গজাল আছে, তাত আমি ৱায়াৰ এনেকৈ ৱাইণ্ড কৰি দিছোঁ আৰু বেটাৰীটো কানেক্ট কৰি দিলে কি হয়, যিটো নেইলটো থাকে, ঠিক আছে, গজালটো থাকে, এইটো মেগনেটাইজ হৈ যায়, মেগনেটিক হৈ যায়। ঠিক আছে, তাৰমানে কি ইলেক্ট্ৰিচিটি ইউজ কৰি আমি মেগনেট বনাইছোঁ। অ'কে, এগেইন তোমালোকে এনেকুৱা চাইছা যে এটা ৱায়াৰ আছে, ৱায়াৰ, ঠিক আছে, মেগনেটটো যদি মই টু এণ্ড ফ্ৰ' কৰোঁ, তাৰমানে মেগনেটটো যদি মই সোমাই দিওঁ বা ওলাই দিওঁ, কাৰেণ্ট প্ৰডিউচ হয়। তাৰমানে মেগনেট ইউজ কৰি মই কাৰেণ্ট প্ৰডিউচ কৰিব পাৰোঁ। তাৰমানে ইলেক্ট্ৰিচিটিৰ পৰা আমি মেগনেটিজমত যাব পাৰোঁ, মেগনেটিজমৰ পৰা আমি ইলেক্ট্ৰিচিটিত আহিব পাৰোঁ। দ্যাট মিনছ ইট ইজ এ কাপলড থিং না, কাপল হৈ আছে, ইলেক্ট্ৰিচিটি মেগনেটিজম, মেগনেটিজম ইলেক্ট্ৰিচিটি, ইলেক্ট্ৰিক মেগনেট, ইলেক্ট্ৰমেগনেট, ইলেক্ট্ৰমেগনেট, ইলেক্ট্ৰমেগনেট। চ' দিছ ইজ ইলেক্ট্ৰমেগনেট। অ'কে, চ' ইলেক্ট্ৰমেগনেটিক ৱেভ তেনেকুৱাই ৱেভ হয়। ঠিক আছে, ইলেক্ট্ৰমেগনেটিক ৱেভবিলাক কি হয়, তাত এটা ইলেক্ট্ৰিক ফিল্ড ভেক্টৰ থাকে। চ' ইলেক্ট্ৰিক ফিল্ড ভেক্টৰ ছাপ'জ কৰা যদি এইটো ডাইৰেকশ্যনত আছে, এইটো প্লেনত, দিছ প্লেন, ভাৰ্টিকেল প্লেন, তো মেগনেটিক ফিল্ড কি হ'ব, এইটো প্লেনত থাকিব, পাৰপেণ্ডিকুলাৰ টু ইচ আদাৰ, এটা প্লেন, ছেকেণ্ড প্লেন, আৰু ট্ৰেভেল কৰিব এইটো প্লেনত। থ্ৰী প্লেনছ আৰ পাৰপেণ্ডিকুলাৰ টু ইচ আদাৰ, ওৱান প্লেন, another plane perpendicular to each other, and the third plane is again perpendicular to rest of two. So in one plane there will be electric field, in another plane there will be a magnetic field, and in the third plane the wave will travel. That means three planes are mutually perpendicular to each other. Okay, so this is an idea about electromagnetic wave, but ultimately it is a wave. Okay, so it will have all the properties or all the things which are there in a normal wave. So what are those? So you all know that this distance, okay, this is called lambda. lambda, or wavelength. This is wavelength of a wave. This is also wavelength, okay? Between two crests or two troughs, the length is called lambda. This height is called amplitude. Okay? Now, see, the particle is starting from here, coming here, then going here and coming here. Okay? It is oscillating about this point. Means 1, 2, 3 and 4. It's coming. So to complete one complete cycle, that means here to here and here to here, this complete cycle, time taken for one cycle is known as time period. Time period. It is represented as capital T. Okay? Time period. Okay? Now see, we will define a new concept which is called frequency. So what is frequency? See, frequency is number of oscillation in 1 second. Means how many these type of waves can be produced in 1 second. That is, how many oscillations can happen in 1 second. This is a slow oscillation. This is a fast oscillation. This is a very, very fast oscillation. So how many oscillations are happening in 1 second? Okay. So oscillation per second is called frequency, and it is denoted by nu. Okay. And or sometimes it can be represented as f, n, whatever. Just keep in mind that if you are using f, then use f always. If you are using n, then use n always. Don't confuse yourself. Okay. This notation, this symbol is your choice. Okay. You must know the meaning. That means frequency is number of oscillation in 1 second. Okay. And we have a mathematical formula that frequency is 1 upon t. That means 1 upon time period. Okay. Now, in electromagnetic wave, I forgot to tell you one thing. The best example of electromagnetic wave is light. Okay, light is an electromagnetic wave. Okay, and electromagnetic wave generally travels with the velocity of light, and velocity of light is known as c. C represents velocity of light. So most of the electromagnetic wave travel with the same velocity, and it has a value of 3 into 10 power 8 meters per second. That means 3 million kilometers per second. Okay, enormous speed. This is an enormous speed. Okay, so nothing can go faster than the light. This is known as cosmic limit. So velocity of light is cosmic limit. It's the fastest that anything can move. So velocity of light. Okay, and you have to remember this value also, because velocity of light is a constant. Okay, so light has a velocity. So now we will get a relation, we will get a mathematical formula, and that mathematical formula will do what? It will connect frequency, wavelength and velocity of light. Okay, and the formula is frequency is equal to c by lambda for electromagnetic wave. For any other wave, frequency is equal to velocity of the wave by lambda. Okay, you have to remember this formula, that frequency is equal to velocity by wavelength. Okay, now we will define another property of the wave, that is called wave number. This is the last thing that I will discuss in this video lecture. Wave number. Wave number defined as 1 upon lambda. What is wave number? Wave number is the number of wave passing through a unit cross section. Okay, suppose if I make a hole here, then how many waves? This is one wave. So how many this type of waves are crossing that unit area? Okay, this is called wave number. Wave number is denoted by mu bar, and we will use these properties in numerical analysis in the later videos. Okay, thank you.